Before we can continue our work, we should discuss something interesting that actually popped into my head. Let's take a look at the foundation that we have here and the braces here that have moved from this level towards the down direction. And you can see the offset shown here. Now if I go over to the north view, these are actually placed under the level, and we don't actually have any levels there. And well, let's see. These that we can see in the plan are actually located under the level. So I'll zoom in here and get a measurement from here to the lowest height of the braces, which is about 1.6, and we don't have anything lower than this. Alright, then I'll close it, and then let's go back to the dynamo. So we don't actually have any use for this right now, so we'll get rid of it and go over here to the sorting section, and then we'll look for the add to front package, and let's see, it's this one that says add item to front, and then we can connect from the list sorting to the item here and hit run. And then let's see what else. So we actually connect the new list to the list down here, and for the item itself we'll add a code block and put in minus 1.6 in it. Connect that to the item and hit run. Alright, so the 1.6 is added here, and we can connect the list to the Y. You know what? Connect the list to the X and then the double to the Y. Run. And let's see, now it's a bit better. Alright, so get rid of this, we don't need it for now. And now in order to repeat this command, I'll go over to the geometry.translate and put a lacing on cross product. Press run, and alright. So right about now, the zones have been identified here, and they're done based on each level. Now we can proceed to the end of the script and take a look at the lists that we have under the polycurve. And alright, I'll use the transpose package to divide each one of these. Connect the list to here and press run. Now this puts the rows and the columns of these into one list, and we can use the rest of items package connected to the script and press run. And yeah, there we go. Now let me just hide these packages, so it's just a bit easier to work with the plan. Alright, so go over here and hide the rest of these, so this one, and we'll only keep the last one. And if we check again, we can see we now have about 108 items in total here, but there might be something wrong. Well, no worries. We can go over to the library and look for the remove last package. Open it up here and then connect the list to here, and now it's just a bit better. And well, alright. In the next step, I'll use right click to search for the flatten tool and open it up. Now I'll get a copy of it, connect this one to down here and this one to here. Press run, and then we get the results. And now I'll use the list create package, add the item using plus, and then connect the items to the two flatten packages. Then I'll uncheck the preview of the two and do the same for these two as well. Now we'll press run, and let's hide the create as well, and well, now it's fine. We can use the transpose package to separate each part and then press run and hide it. Then I'll look for the solid biloft package, open it up here and connect the cross sections to the lists. Run, and okay. Now we can see we get a box for each one. Now we have our zone area inside each and every one of these, and we can see them in the plan if we go through the list and select the items. And you can see each one of these are now used as a box. Now let me go back here and check the preview of the transpose in order to see the lines, and we can see the structure if we rotate it, as such as here as well. Now, in order for us to be sure that all of the elements are inside of it from different angles, we can edit the 1.6 in the code block over here to 2, because it's more helpful to increase the size of them. Then I'll add a code block over here and type in x plus 1 meter inside of it. Connect the code block to the list here and to the code block up here from the other side. Press run, and we can see the added sections from the upper and lower bits. And this way we can be sure all of the items are within the space. Alright, so let's keep this up to here. And then I can open up the background 3D preview and check the preview of the Revit background through the menu here. Press run. Alright, let me disconnect this and press run once again. Reconnect and run again. And alright, so everything seems fine up to this point, but we should be able to see this. In order to be sure, I'll open up the visibility graphics menu and check the generic models and press OK. And alright, there you can see it. Now we can see these because they were under the generic model family, and the preview is activated right now, and we can check out the surrounding area. And if we check it out from the north view, we can see everything is inside of the space, and we get the same confirmation from the 3D view as well. But the only part remaining is the code block here. Let's change this to 4 and press run to see how we can shape this part. All right. This time let's change it to -20, and let's see. There it is. Let's go with 8 this time, and well, I'll say this looks better. Let's just try out 7 as well, and then let's see. All right, 8 was just a bit better. We'll go with that. So now we're pretty sure that all of the elements that we've modeled are located inside of the model boxes here in the plan. And now I can go back and save the dynamo up to this point. And now we want to export the script and the settings into a SAT file. So I'll use right click to open up the export to SAT package. Connect the geometry to solid, then add a file path here. Press the browse option, and well, let's see what the name of the last file was. All right, it's 12, so copy and paste the name and change the format to SAT and hit save. Connect this to the file path, save the dynamo and hit run. Excuse me, I just had to put the unit on meters here before we can proceed and hit run. Now it's all fine.